Hi, I'm Martin, and in this Nexperia video series we will explain why we use TLP to characterize our ESD protection devices. Without doubt, the most important standard for system-level ESD protection is IEC 61000-4-2. It defines immunity requirements and test methods for electronic equipment that can be subject to electrostatic discharges from humans. The defined pulse waveform has a very sharp first peak. In only 1 nanosecond, the pulse reaches its peak current. The total length of the pulse is around 100 nanoseconds. While all of our ESD protection products are rated according to this standard, it is not very useful for characterization as it only gives pass-fail or maximum robustness information. To gain more insights into the switching characteristics of an ESD protection device, another test method is very useful: TLP, transmission line pulse. The standard TLP with a pulse length of 100 nanoseconds and a rise time of 1 nanosecond delivers a pulse that has strong similarities in rise time and pulse length with an IEC 61000-4-2 ESD pulse. This is why, for TLP, the protection devices perform very much the same as an IEC ESD discharge. With TLP, however, precise inline measurements of current and voltage during the pulse are possible. This enables the creation of a characteristic IV curve that perfectly describes the behavior and performance of a protection device. With a fine-grained control over the charging voltage, TLP can also be less destructive. The failure point can be determined more accurately than with IEC 61000-4-2 ESD discharges. Additionally, TLP is very well reproducible and yields stable results for subsequent measurements. All this makes TLP ideal for characterizing the switching performance of a protection device. The TLP characteristics are essential for comparing protection devices and finding the right protection for every use case. Thank you for watching. I hope to see you again in another Nexperia video.